Good evening to all. A warm welcome to all of you to this special occasion as we celebrate World Quantum Day 2025, organized by the Institution of Engineers India Serum Local Center. As you already know, the Institution of Engineers India, established in 1920, is the largest multidisciplinary professional body of engineers in India, with over a million members across 15 engineering disciplines. It promotes the advancement of engineering and technology through professional development, research, and knowledge sharing across its 125 plus centers in India and overseas. Now, to officially commence the session, I wish to again deliver the formal welcome address. Respected today's chief guest and keynote speaker, Mr. Srikutan LS, CEO and co-founder of Block Quantum Kollam, our beloved Honorary Secretary, Dr. C. Domini ma'am, esteemed council members, distinguished engineers, honorable office bearers, members of IEI, students, invited guest, our IEI staff, Engineer T. Thiagu. A very pleasant and intellectually stimulating evening to one and all present here. It is my great pleasure and privilege to welcome you all to this World Quantum Day celebration organized by the IEI Serum Local Center as part of our continued mission to explore emerging and transformative technologies that are shaping our future. Every year, April 14th is globally celebrated as World Quantum Day, commemorating this significance of Planck's constant H equal to 6.626 and honoring the foundational principles of quantum physics, an area that has redefined how we understand the universe at its most fundamental level. Quantum science is no longer just a theoretical curiosity, it is a disruptive force revolutionizing domains like computing, cryptography, material science, artificial intelligence, and communication systems. As engineers and innovators, it is crucial for us to be aware, informed, and involved in this paradigm shift. I'm extremely delighted to share that we have among us today a dynamic personality and a passionate educator in the field of quantum technologies, Mr. Srikuttan LS, co-founder and CEO of Block Quantum Private Limited, Kollam, and a prominent quantum educator known for his pioneering contributions in quantum learning, research, and outreaching across India. He will be addressing us today on the very timely topic, importance of World Quantum Day and the future of quantum, a subject that holds immense potential for our engineering and the scientific community. Sir, we are truly honored by your presence here with us this evening, and we eagerly look forward to your thoughts and insights. Before we begin the technical session, I would like to take a moment to express my sincere thanks to all the members, students, coordinators, and organizing team who have made today's program possible. Let this evening not only kindle our curiosity, but also inspire our commitment to foster scientific temper and technological excellence in our institutions, classrooms, industries, and society at large. Once again, I warm welcome to each and every one of you. Before handing over the session to our chief guest, I want to give a small introduction about our today's chief guest. We are delighted to introduce Mr. Srikuttan LS, the co-founder and the CEO of Block Quantum Private Limited, a cutting-edge quantum software startup based in Kollam, and alumnus of IISER, Pune, one of India's premier research institutions. Our chief guest is an expert in quantum algorithms with a special focus on quantum machine learning. Before founding Block Quantum, he served as a product manager at the Quantum Insider, a leading Canadian quantum intelligence company, and also contributed to uh, QCRISI, gaining deep insights into quantum ecosystem. Under his leadership, Block Quantum is pioneering enterprise adaptation of quantum computing through a user-friendly low-code platform. The tool simplifies quantum algorithm development, making it accessible to users at all skill levels and delivering a tenfold acceleration in development along with valuable business insights. Block Quantum recently gained national attention by securing 1.3 crore in pre-seed funding from Infection Point Venture and Happy Llama to enhance product capabilities and expand the team. Also, Block Quantum won third prize in the prestigious Fujitsu Quantum Simulator Challenge 2024 for developing optimized quantum kernels for credit card fraud detection, an innovation that has already been evaluated by a major insurance company. Our chief guest also authored three research papers, filed few again patents, and continues to be a passionate advocate for leveraging quantum technologies in domains such as AI, deep learning, IoT, and blockchain. So please join us in warmly welcoming our chief guest, a visionary leader shaping the future of quantum computing in India and beyond. Now, with great anticipation, I invite our chief guest, Mr. Srikutan LS, a trailblazer in the quantum field and co-founder of Block Quantum, to deliver his keynote address. Sir, now the floor is yours.
Um, Hope I'm visible and audible. Somebody can confirm. Am I visible and audible?
Yeah, yes, sir, visible, sir.
Okay, great. But I can't see myself. Yeah, yeah. Great. Thanks a lot for the wonderful introduction. I think you've done some good background check on me, so thanks a lot for that. It's just lovely, and it's actually really um, you know, wa- heartwarming to see such initiatives. And I'm so glad that this is happening in India at this point of time. So, um, just a little caution before I start to speak, because one thing is I have a very busy schedule, so I couldn't prepare anything. So I'll just say whatever comes into my mind. I'll try to make it more interactive. I think that's what will help, hopefully. So rather than me talking a lot of time, I'll be happy to take in questions because I think it's very, very new. Um, and there'll be a lot of misconceptions and a lot of misunderstanding about this industry as well. So I'll be happy to take in more questions from the audience, and I'll be happy to, reduce the time that I talk. So hopefully this will be like a two-way interaction rather than just me doing my monologue. So I'll give you a background um, for you to, start thinking about quantum computing. So I come from a niche area in quantum technologies called quantum computing. So April 14, the quantum day, it actually signifies quantum sciences. It actually celebrates quantum science. So it doesn't only celebrate quantum computing. So it is, hopefully if you have read, the it is being taken from Planck's constant, which is 4.14 into something, something, something. So that's why 4.14, 14th April comes. So it celebrates the fundamental science behind. There is some noise, like a notification coming. I think, I don't know from where. If all of you can switch off your mic, that'll be great. Um, I think there is an IEI SLC, probably from that. I'm getting that noise, but yeah. So we celebrate quantum sciences, the foundation of what has led into this industry, quantum technology industry. It has been uh, paved by uh, it has been paved by Schrodinger, Planck, Niels Bohr, Heisenberg, Einstein, and also around Satyendranath Bose, S.N. Bose. So these are the pioneers who actually built the foundations of quantum mechanics. Paul Dirac, and a lot of them are there actually. Um, so all these scientists laid the foundation for quantum mechanics, which then have became the foundation for an industry which uses quantum mechanics to build different applications. So earlier we studied classical mechanics. I think most of you would be familiar with classical mechanics of the Newtonian mechanics, like Newton's the gravitational laws of gravitational laws and everything, which is pretty similar, which is pretty intuitive. But quantum mechanics is completely counterintuitive. It looks into a world which we can't see through, we can't see with our bare eyes. You need um, very highly specialized equipment to actually, look at these systems that we call as quantum systems or quantum particles. So I think if you can, so that notification is still coming. That notification ting ting sounds. Probably if you can switch off the mic of IEI SLC, that'll be great. Yeah. So I like that. So that foundation has led into a sprawling industry of quantum technology. So using quantum mechanics, we can build powerful computers, much more powerful computers. So we call them quantum computers. And using quantum mechanics, we can build powerful sensors, uh, powerful devices, which actually helps you to measure very, very minute changes in physical entities, physical quantities like gravity, magnetic field, and others. And that is the quantum sensing and metrology part. And then using quantum mechanics, we can build some of the best communication infrastructure for the internet, which will be completely safe, which can never be never be broke. It can never be hacked. So this sort of things comes under something called communication, where you can communicate um, through through the internet very, very securely. That comes under quantum communication. So these are the three broad aspects of quantum mechanics and which builds upon which have constituted quantum technologies. So there is quantum communication, there is quantum computing, and there is quantum sensing. So each industry, each of these category itself is a huge industry in itself. So I'm not an expert in quantum physics. I'm not an expert in quantum communication. I know very little. Just want to let you know, but I hope I know a little more about quantum computing, so I could talk more on that. Um, so I think this is the premises for you to start for you to start asking questions. I think I'll invite people to ask questions at this point in time because I really don't know what to say after this because I could go to quantum computing and go in depth. I could talk about all of these things in quantum computing. I could go um, into sensing and also communication. So I'll be happy to get questions and then I can talk about the future and India's efforts and other things. So I'll be open to questions at this point in time. So either you can put it in chat or you can unmute yourself and ask. Okay, nobody has any questions. Okay, that's great. Um, Cool. You can ask. So I think the questions can be as simple as what is quantum computing, because it's such a vast field. Nobody can put that in 45 minutes. So that's why I just don't know what to say, right? So I'll be happy to take questions where I can talk about that if you have anything laid out on things. It's okay. Now to come into where are we right now? So quantum computing is still in very nascent stages. There is few quantum computers that is currently available, but they are in a very early stages. Give somebody a pause. How quantum will affect or impact in place of data? I don't understand the question. If we can probably um. So Giridharan, can you please unmute and ask the question?
Sir, good evening, sir. Sir, how quantum will like improve in the place of data, sir? In data science or uh, uh, data analyst or data science, how quantum will change these fields, sir, or affect these areas?
So, um, so data, when we say data, I think we should shift our focus to big data and not just big data, very big data. I think that is where quantum computing and actually comes in once it is ready. So that's something very important. We are still not yet there. Our current quantum computers can't do anything. Hopefully within 5 years it will be ready. Once it is there, you could actually do computation, you could actually do analysis of this very big data much faster than the current computer. So it is going to be very useful, especially in machine learning part. So of course it's going to affect big data, um, architecture and how you do big data, hopefully within 5 years. Application of quantum computing. So Dr. Vasandi, it's a very broad question. There are application of quantum computing in multiple industries. What I'll suggest is to hope, because again, that itself is another 1 hour, 2 hour session. Um, f- Main applications are in finance, healthcare, logistics. I think these are the three main industries that has applications. Again, in these industries, there are multiple use cases. So the best way to actually would be to look into ChatGPT. Ask ChatGPT what are the applications of quantum computing. First ask them what is the um, industry that ChatGPT industry that quantum computing will affect, and then in each of this industry, what are the use cases? Again, a lot of so there are 10 plus industries, and there are 400 plus use cases that we've already identified. How will you realize the qubit? So um, again, that's a one that's somebody's PhD thesis. So I can try to condense that. So in classical computing, you use electricity, voltages to represent bits. That is, high voltage will be 1 and low voltage will be 0. But in quantum computing, it is completely different. We use actual particles to define a qubit. So let's say you have a you have an atom or you have an electron. So there will be physical properties. When I say physical properties, if you remember your 12th science physics class, you would remember each electron has an energy if it is in an atom, right? Each in an energy level. It'll be in an energy level and it'll have a particular energy associated with that energy level. So, for example, that energy is a physical property. Then, if it's a photon, spin is a physical property. So, there are multiple this sort of physical properties. Now, what usually people do is they'll uh, constraint or they will um constraint this particular physical property into two distinct layers or two distinct levels. So that is where bit comes in, binary. So we'll constrain that into uh, we'll put that particular system into two different layers. Then we'll call one layer as 0 and one layer as 1. So there is multiple realization of qubits. It can be through electrons, it can be through atom, it can be through proton, it can be through ions. It can be through topological qubits, it can be through nitrogen vacancy, diamond centers, NB diamonds. A lot of them. There are 10 plus. Again, ChatGPT is your best bet for that. There are some key areas. Tagan, if you can ask this question right to me, right? If you can unmute and ask, that'll be great. Tagan, please unmute and ask these questions.
Yeah, actually, India is building momentum in quantum research. So, what are the some key areas where our country can lead our contribution globally in this quantum computing domain? That's my question, sir.
So there is no direct answer for this, because it's much more nuanced than that. There are two observations that I've made, and two of the observations actually point towards two different answers. India has always been known as a software powerhouse. Again, not as like service powerhouse. People outsource their software to us. Look at Infosys, Wipro, and all these big service giants, right? So we are really good in software. We have been really good in software. We are one of the biggest software engineering talent pool. So so from that perspective, from that observation, we think software, quantum software. So of course, you can build all this quantum computer, and then you need software to do anything useful on this computers. We are in the quantum software. We are building quantum software. So that comes naturally to us. So that is one area I think will be India's shine. But once you look at National Quantum Mission and their particular interests, their focus areas, it's a completely different picture there. They're looking more into hardware. I think it is because most of the quantum allied institutions has been historically academic institutions. There has been tons of academic research that have been happening since more than 50 years in India. So Indian government has naturally aligned towards that because they think they are the deciding factors. They are the authorities in quantum computing. So in hardware, what I suggest is you should look at National Quantum Mission and for the four hubs that they've created. So there is one hub for quantum computing, one hub for quantum materials and devices, one hub for quantum sensing, one hub for quantum communication. Again, our 8-year goal is to build a quantum computer in 5 different modalities or 5 different ways. It can superconducting, photonic, neutral atom based. So build a quantum computer. And then in quantum communication, I think it's much more. Well, I don't know much specific into it. So I think it is going to have a change. That's what I feel because India's historically being late mover in all these advanced technologies. India is still a late mover in quantum. It's pretty late, but it's not dead late. It's not like dead on arrival date. Like we are trying to do for building an LLM, right? Our own LLM. So it's not like that late. We are there. Hopefully, um, I'm a hopeful, but an optimistic guy. So all these national quantum mission projects become into fruition and everything becomes succeed. So within 10 years, we'll have some of the best entry-level quantum computers. So when I say entry-level quantum computers, that quantum computers won't be good enough for anything. So again, that's it. So my bet is in quantum software because I don't think because we are still hopefully within 20 years, 30 years, we'll have cheaper quantum computers in India, like useful quantum computers. But 10 years, it's really hard for us to build really good quantum computers. Because when we're talking about qubits, like 25 qubits, so our maximum something that we have achieved is 25 qubits. Other companies are doing in 1,000, 5,000 ranges in US and others, and they've been moving towards other much more advanced qubits called logical qubits. So we are not at there. So that's why I think software will again be our best bet because that comes much more natural. The starting cost is much more less. You don't have to have a lot of capital to build these things.
Actually, I want to combine my next question with Dr. Vasanthi ma'am's question. How to create interest among students in quantum computing? And as a startup founder in the quantum space, what inspired you to create actually Block Quantum?
So I'll take it on the first question, like interest towards quantum computers from students. Um, so I've seen a lot of students. I've interacted with a lot of students um, who are really interested and curious about the weirdness of quantum computers, like weird formulas, not formulas, weird um, phenomenons in quantum computers. I think that is where you should start because if you understand the underlying principles of quantum computing, it's very counterintuitive. You would never imagine something like this will happen in another world. So, for example, if you take quantum superposition, it's crazy, right? So, a photon or an electron can be at the same time. It can be in same different places. So, it can be at the same place. So, for example, me being here and me being in Salem, the same place. It's not possible, right? But it's possible in the quantum regime. So, there are these fascinating phenomena, fascinating spooky little spooky phenomena that you could actually tell them and pique their interest. So look at quantum superposition, look at quantum entanglement, and these are very sort of counterintuitive ideas, counterintuitive themes that will definitely take um, interest of people, research students. That's the first step. Hook them up with the the foundations, and then I think talk them about the future that they'll have they start right now. So of course, after the foundation, after hooking them up with all these things, you might want to also give them sufficient materials to learn. But the most rewarding purpose would be there are very few proper quantum talent in the whole wide world. If you start right now, in 5 years or 10 years, you could be in a position where you could say, I'm working at OpenAI. Right now, when we say somebody is working at OpenAI, think what is the status that they are? What is the not just the status of so Facebook, Google, Meta, everybody, like all these companies was 5 years back. When people say I'm working in Google, they'll be like, wow. But right now, when people say I'm working at OpenAI, I'm working at Anthropic, I'm working at cloud, that is when everybody be like, wow. So that wow will change in 5 years to quantum computing companies or 10 years to quantum computing companies. So in future, people will be like, when people say I'm working at Block, then they'll be like, wow. So that is where the career shift, if you want to make it really big, you want to have a positive impact in whatever you do, because this is not regurgitate repetitive work that I'll be doing. You'll be doing cutting edge work all the day long. Um, So it will be one of the most rewarding career, uh, and that is where you should hook them more and take them to quantum computing. Um, and why I started Block? So that actually is because of my background in physics. So I've been in physics for God knows when. Like um after I come to IISER Pune, I've studied quantum mechanics. That was the only subject that actually gave me good marks. So that was surprising. Even though it was the most difficult one, it really piqued me. But I was actually a very average student. I was not a great student. So this interest actually helped me to understand there is an industry called quantum computing. I was introduced to that. And later I understood, okay, I'm not cut out for PhD, so I'm not cut out for like academic research. And naturally I levitated towards an entrepreneurship route. I don't know, like it doesn't seem like a natural step, but it was the most sensible step for me at that point of time. Because the opportunity is massive, and the passion. I'll always have the passion for doing something on my own. So that was my journey. That was my trip towards quantum computing.
Yeah, thank you, sir. Actually, my side lost one question. An engineering student without a background of physics, also interested to build a career in quantum technology, means where should they begin?
Engineering student without a background in
Physics.
physics. Okay. Uh, so that's pretty much easy. The strategy is pretty much straightforward. Look at your strengths. So when I say engineering, it can be computer science engineering, it can be electronics engineering, all these types of engineering, right? So look at what's your core strength. So if it is computer science, levitate towards um, quantum programming. So start quantum programming. There is Python libraries that will help you to do quantum programming. Start with that. So if it is electronics student, so if you have an attraction towards this, if you have an attraction towards engineer a code, do that. Go do quantum programming. Now, if you have an attraction towards hardware, probably if because of you are from electronics engineering on all this background, right? Um, then I think it'll be really interesting for you to look into quantum electronics as well. Like not quantum electronics, quantum hardware area. Because most of these elements of building a quantum computer, of doing hardware, actually stems back to uh, simple electronics. So you might be building accessories for a quantum computer. So because it's not just a chip, right? You might need to connect all these things into multiple devices to reading out and to sending information. So look into the again, ChatGPT will be a friend there. Ask ChatGPT what are the components of a quantum computer? Where can an electronics engineer like me can go on and build something, right? Go on and help or go on and do something on my own. And then if hardware is something you should really do, you can probably look into doing a hardware quantum experimentation project with some of the professors uh, in India, and then take it from there. So then you can shift to our industry. So that's a plan. Software, if it is software, if you do love coding, do quantum programming. It's easy. There is not much physics involved. It's as simple as writing a PyTorch or a TensorFlow code.
Yeah, thank you, sir. Actually, participants, if you have any question, please unmute yourself and ask with our expert, or you can post in chat box also.
So I'll wait for one more minute, then I'll do the closing remarks.
Yes, sir. So one question from our participant: what are the challenges did you face in setting up a quantum-based startup in India, and how did you overcome them?
No challenges. So it's not difficult to actually build a setup right now.
Mm.
So then, to be honest, if you the only thing you need to be very sure is that are you the right person to do something like this? Like, do you have the enough technical background and enough business acumen to do something like this? If you have all these things and everything, then it's actually not a challenge to do anything. Um, so for that person, what I'll ask is become an expert in this industry, or else don't do and set up in this industry. Um, but of course, right, to set up a company, there was no challenge. But of course, running company, there's always challenges.
Sir, actually, what is your message to actually academic institutions and also policymakers in quantum computing on building a vibrant quantum ecosystem in India?
So, I mean, academic institutions, I know the roadmap is very simple. Um, Introduce quantum computing courses. Either it is like a workshops, simple, small 2-day workshops, or a semester-long course. A lot of the institutions are actually doing that. That'll be very key factor for you to actually do something. Become a flag bearer uh, in this industry, and then try to build a center of excellence to actually help streamline all the process and initiatives in quantum computing. A very important step to do that. Along with that, um, so look at what is West doing. West is doing like they're doing phenomenal work. So I've been in touch with few people. So there are senders, there are hubs which actually connects with industries. When I say industry, companies, like big companies, and then academia, and then startups. And that is a question that is so strong that will take this industry to a next level. India doesn't have something like that. India will have standalone hubs, standalone centers and institutions, and then there will be like um, companies doing something alone, and then there is all these enterprises who are completely clueless about quantum computing. So we need to bring all of this together. Unless until this is not happening, it'll be really bumpy, right? So institutions doing good, academic institutions are doing good. They need to improve their pace, and they try to bring these enterprise customers, like customers, to actually into this ecosystem to build something useful for them.
Sir, one question from Dr. A. Ilavarsan, sir. Could you share a turning point in your journey as a quantum educator or entrepreneur?
So I can't say there was a turning point in my journey, especially as an entrepreneur, because all the all the steps were like uh, s- all of the steps were very small steps towards something that I don't know what was a. So when I was back in third year or fourth year, that is when I realized, okay, real rigor academic research is not for me. I don't know what next. So back in fourth year, I didn't know what was next to me. So there was all these small steps that I took, which went along. But um, I think one, so few of the bigger leaps there was after working for Krishi, an Indian startup, I actually got into a Canadian startup. So that perspective that helped me working in a global company, Canadian global corner company that actually helped me. All these steps actually boosted, not actually giving more confidence on yes, I can build this because I was sitting in my home, in my room, in my village in Kollam, a tier 4 city nobody have heard about. In Kerala, like again, not famous for startups, not in Bangalore, not in Chennai or anything, right? So again, all these steps, they were little small steps that I took. So I think that um was my journey. There was no big turning points as of such. So
Yes, sir. So,
the
final question. Actually, what advice would you give to aspiring engineers interested in disruptive technologies like quantum computing?
simplest build stuff. Build stuff. Go and build stuff. Don't read, don't waste your time reading, don't waste your time learning. Go and build stuff. So if you waste your time reading, if you waste your time, trying, okay, I'll learn this and then I'll do. No. Look at okay, what are the what again, look back into what is the core strength? You might be good in programming, you might be good in electronics. Then go and do stuff. That is the that is a paramount important thing that you need to do. So don't waste your time reading and learning. Of course, by doing stuff, you'll learn and learn. You'll be reading and learning because you want to do stuff. I think it's already 45.
Yeah, yeah. Thank you, sir. Thank you for your time and also for your enlightening and visionary address. Um, actually, participants, you have if you have any actually questions, please post to our mail ID. We will forward it to our expert and we will get back you. So thank you, sir, for as I already mentioned, very deep again enlightening and visionary address. To conclude today's session, I invite our honorary secretary, Dr. C. Domini ma'am, to deliver the vote of thanks.
Thank you, sir. Most respected our chief guest and keynote speaker, Mr. Sri Kutan sir, our beloved chairman, Dr. K. Thangaraj sir, respected committee members, council members, Mr. Tiago, and students from various organizations. Good evening to all. It is truly an honor for me to extend this vote of thanks at the conclusion of this insightful and inspiring webinar on the importance of World Quantum Day and the future of quantum. This is the special webinar, 75th special webinar of World Quantum Day 2025 under the aegis of Computing Division Board. On behalf of IEI Salem Local Center, my heartiest gratitude to our chief guest and keynote speaker, Mr. Sri Kutan sir, co-founder and CEO, Block Quantum Private Limited, Kollam, and a prominent quantum educator. Sir, actually, your expertise, inspiring insights, and engaging discussion have not only deepened our understanding of quantum science, but also give a spark and curiosity about the possibilities that lie ahead. Thank you for your for sharing your valuable time and knowledge with us. Thank you, sir. My sincere thanks to our beloved chairman, Sir Dr. K. Thangaraj, our dedication and hard work always putting to conduct like this event. Thank you very much, sir. I extend my sincere thanks to our engineers talk team members, Dr. R. Satish Kumar, sir, Dr. A. Kumaravel, sir, Engineer N. Arumugam, sir, Engineer K. S. Selvam, sir, for their continuous and guidance and support. It's my privilege to thank Mr. Tiago for his support and ensuring everything is run smoothly. As we celebrate a World Quantum Day, let us carry forward the spirit of scientific curiosity and collaboration. Quantum science is not just future, it is shaping our present. Whether it is a computing, communication, cryptography, or sensing, quantum technologies are redefining the boundaries of what is possible. So, in a closing remark, thank you all once again for making this event a successful. Thank you once again.